In a previous video, I demonstrated how to set up the Reach RTK module, load it with firmware, and do a configuration in single mode. And what I want to do in this video is demonstrate how to set up RTK where your base is sending corrections to the Rover module. On the left here, you can see that I have the base module. I do have that labeled B because these are both on the same network communicating over Wi-Fi, and it's obviously hard to tell the difference. This one on the right is the Rover module, and I won't be going into detail about these ground planes in this video. I just wanted to show you guys these are cut out from a real thin aluminum sheet that I bought from Home Depot, and then cut 10-centimeter circles, so 100 millimeters. I was doing some reading in the EMLID forums about the ground plane, and one of the representatives from Talisman, the guys that manufacture that antenna, recommended a minimum of 10-centimeter diameter ground plane. I am currently in the backyard. Both of these are powered up with 5-volt micro USB cables. These are both on my network. The Rover has a client that is communicating with the base saying, hey, give me corrections. Now I want to demonstrate how we actually set that up. Let's take a quick look at the end result of what we ultimately want. So you can see our status here is float. We want that to be fixed, but we're going to cover that in an upcoming video to get that precision locked in. But what you can see here is, if you remember previously when I had the single Reach unit running, we had the colored bars are yellow and green. That represents our Rover. These gray bars actually represent our base. So that tells us that RTK is set up. You can see our mode is kinematic. And when we have a status of float or fixed, not single, that tells us that RTK is working properly. This is the Rover at IP address 10.0.1.15. and my base is at 14, so I'll go ahead and stop that. And once again, these are configured on the same network. I'll go ahead and refresh this page. You can see here's our base. You will not see GPS signals in here, and I've read that that's going to be in an upcoming version of the firmware, so just make sure that you pay attention to that. So I'm going to go over to config for the base. What we want to make sure that we have set up is TCP server. Now this is going to be the endpoint that the client, the Rover, is communicating with. You can set this port to whatever you want. By default I'm using 9000. This default format of RTCM3 is just fine. Now here's an important thing, not for today but definitely for in the future. We're going to need accurate coordinates on the ground for our base station. I just grabbed some coordinates that the Rover was producing and I pasted them in here just for demonstration purposes. So you're going to want to have those specified, and in an upcoming video I'll walk through setting those up accurately. So we'll go ahead and just click save and load. Those are our settings. We'll go ahead and move over to the Rover. The Rover has a lot of different settings, and to be honest, I don't understand all of them just yet. I just want to demonstrate the base settings that you need to get RTK actually working. So by default, in the last video we had set up the single configuration where the Rover was getting information from its own GPS. In this case, we're going to select kinematic default, and then we'll go down and select kinematic here for the positioning mode. And the only other settings we'll need to mess with is the input source for base corrections. Now remember, for the base we set up the server by selecting TCP server. In this case we're going to set up the client, and once we specify that, we're going to enter the IP address of the base. Now once again, since these are on the same network, we have 10.0.1.14. Over wireless, this is going to be asking the server for corrections, and if you remember, we want to specify the same port that we had on the base. So 9000 RTCM3 for the format for base corrections, and that's all we need to do. We'll go ahead and click save, and yes, we want to load the current config after save. Now those are the basic settings to get RTK working. That took me a little while to figure out, spending time in the forums and just doing some different tests. What I want to demonstrate next is, let's go ahead and start our Rover GPS. I'll go ahead and move over to the status screen, and what we'll see is, even though we're in kinematic mode, it'll say status single, and we'll only see the GPS bars from our Rover. Now, that's actually because I haven't started the base. No corrections are being sent over. So what I'll do now is we'll go over to our base, and I'll go ahead and click start. We'll go over here, and you can see that automatically that there's communication happening. Our Rover client is communicating with our base server, and just in a few seconds we'll start to see this status change from single to float, or hopefully fixed, which means we have RTK working properly. You can see our status here is float. Now, this will fluctuate a little bit just based on signal. There's all sorts of different variables here. As I mentioned before, we ultimately want those ground planes set up, and we do want that status to be fixed. If you look at the Reach RTK docs, it says float. Base corrections are now taken into consideration, so that's good. We're communicating. And positioning is relative to base coordinates, but the integer ambiguity is not resolved. And we want to strive for fixed. The positioning is relative to the base, and the integer ambiguity is properly resolved. This is as good as it gets. That was a brief tutorial on how to set up these Reach RTK modules. I'm just incredibly impressed with how easy they are to configure through the web interface. So very excited about that, and our next steps of increasing range and improving accuracy. If you guys have any questions or comments, please post them below. And until next time, thanks for watching.